Okay, in this video, we're covering another example of a Shannon decomposition. All right, so in this case, what I'd like to do is start with a 4-variable logic function and decompose that using 3 select variables. So the idea here is I have a multiplexer with 3 select lines, and I'm going to use the inputs, so we're going to be A, B, and C as the select lines. So I'm doing a Shannon decomposition with A, B, and C. All right, so I put this straight onto a Carnot map because I think that's the easiest way to make these happen. So what you do here is you take a look at the various input cases. All right, so with a select line, you can have all zeros, right? There's 8 different possibilities because we have 3 lines. So starting with the first one, all zeros. Okay, when I have all zeros selected, I look at where does that happen on the Carnot map. So here's where A and B equal to 0, and here's where C is also equal to 0. So it's these 2 squares on the Carnot map for data line 0. All right, so it's pretty clear that needs to be tied to a 1. All right, now let's go to data line 1. All right, so data line 1 would be 0, 0, 1. All right, so I'm looking on the Carnot map. Where is 0, 0, 1? And again, A and B are 0, 0. And then I look to see where C is a 1 and C is a 1 here. So 0, 0, 1, that's these 2 squares on the Carnot map. All right, so from there, I need to look to see what's the correspondence between the Boolean function f that I'm trying to implement and this particular region on the Carnot map. So the correspondence here is you look at the variable d. So when d is a 1, f is a 0. When d is a 0, f is a 1. So it's pretty clear that on line 1, we should put d bar, because in that region of the Carnot map, when I have these select lines asserted, then f follows d bar. Okay, so that is the blue region. All right, so let's move on to line 2. Okay, so for line 2, 2 is 0, 1, 0, and so I find that region on the Carnot map. All right, those are the questions you ask yourself. If I have 0, 1, 0, if I have a 2, what region on the Carnot map is that? Okay, so I look at the variables A, B, and C, 0, 1, 0. That would be these squares here. All right, and so then I ask myself, well, how does F relate to D for those 2 squares? All right, so here's the variable D, and it looks like when D is a 0, F is a 0. When D is a 1, F is a 1. All right, so for line 2, the output F follows D. All right, I made that one also blue. I should have done a different color. Let's make it green. Okay, so that's the green part. Okay, and then let's go to line 3. All right, so line 3, 0, 1, 1. I think it becomes obvious. You start to see a pattern where this would be line 3. Okay, and it looks like it's following D bar. It looks just like it's the same pattern as line 1. Okay, so D bar. All right, line 4. 4 is 1, 0, 0, so we would jump down on the Carnot map to here. Here's line 4, so I would tie line 4 to 1. All right, line 5, 1, 0, 1. That would be this region of the Carnot map. Hopefully you're following that. Let's just go over it to be sure. 1, 0, 1. A is 1, B is 0, C is 1. That's this gold region of the Carnot map. Okay, and so what does the output F do in this case? Well, it looks like F follows D for line 5. Okay, And then line 6, okay, line 6 would be, let me get a different color. Let's do a dark green. Okay, line 6 would be 1 1 0, 0 for the C. 1 1 0 is right here, and it looks like that's obviously just 1. All right, and then line 7 would be the remaining part. I'll put that in gray. All right, and so the remaining part is following D bar once again. All right, so there's an example of Shannon decomposition where you have 3 input lines, or 3 select lines.